Welcome to Maths with Bob. Today we're looking at just a beginning introduction to what's called set theory. And you can see here we have three sets, A, B and C. We're using this set notation, the curly brackets if you like. And A has the elements 1, 2, 3 and 4. If you like, the number in set A is 4 elements. They're the individual numbers 1, 2, 3 and 4. In B, set B, you can see here we've got 5, 2, 4, 6, 8, 10. And in C, again, we only have 4, 1, 4, 9 and 16. So we have three sets, A, B and C, and we're going to look at unions, intersections and the ideas of complement, the complement, not the event, or not the elements in that particular set. Okay, so we're going to have a look at these ideas shortly. Well, okay, let's actually have a quick look at some unions and intersections. Now, in set theory there are some symbols we have to look at. Union, intersection, there's actually a subset one on the side as well. But just at the moment we're just going to be looking at some simple exercises and looking at the unions and the intersections. Okay, you can see here we've got the same sets as before, A, B and C. Okay, A union B. Okay, they are in sets A or B, and you can have a quick look. Just having a quick look, these are the two sets involved. Which ones have we got in both those two sets? So it's like the addition of the two sets. You might think of it like that. Okay, so what would it be equal to? Well, we normally write the set notation idea using the curly braces. Okay, so we have 1, okay, 2, 3, 4, 6, 8, 10. Now 6, 8, and 10. Now you notice we do have a bit of a doubling up of a couple of elements there. I think it's the 2 and the 4, and we only write them once because we just want a list of the elements in the union. Okay. How about B union C? Have a look at B union C. Okay, let's have a quick look. B union C. Okay. This would be just the ones which are common to both B and C. There we can see 4 is actually a common element there, so it's 1, 2, 2, 4. Okay. 1, 2, 4, 6, 8, 9, 10 and 16. Okay. So sometimes we could say that if you like, you can write something like this. Okay, the number in the B union C, the number in the union is 3, 6, 8. So we could say that the number in the union of B union C is in fact 8. Sometimes we use that idea. So let's have a look at A union C now. Okay, A union C. Well, one's common, you can see here, to both of them. That's actually the overlapping element or the intersection. Okay, so also 4 for that matter, A and C. But let's actually write down the union to start with. The union would be what? 1, 2, 3, 4, and 9 and 16. 9 and 16. Okay, so these would be the elements. We list them with commas in between them. Okay, so they're individual elements of those sets. Now, A intersection B. If we have a look at A intersection, now intersection is in fact the overlap, or if you like, A and B. So they both have to be in A and B together. So let's have a quick look. A and B. Okay, well there is a 2, yep. And there's a 4, right, okay. So the intersection is just those two elements, 2 and 4. Okay, so we'd write the equals, okay, set elements 2 and 4. How about B and C? Now, B and C, okay. Well, B and C have only got 4, okay. So B and C have only got 1 element, okay. So B and C is just 4. Okay, that'd be. How about A and C? Okay, 1 and 4 as well. Okay, so all right, so we have 1 and 4. Okay, so we have 1 and 4 in the intersection of A and C. Now we're going to be looking at more complicated ones in a minute, and but basically you can see that if I said to you what was the complement of A union B. That would be the elements which are not in the union of A or B, okay, So we'd have to look at, in terms of this other set C, which if we're assuming there's only 3 sets A, B and C, there's only going to be a couple of elements, I think 9 and 16, which would be in the complement of A union B. And we're going to look at these ideas. And the idea of a complement is basically logic of not. Example, for instance, if you roll a die, there's 6 faces, 1, 2, 3, 4, 5 and 6, and the complement of the event of getting a 6 or rolling a 6 would be not rolling a 6, and that would be the faces 1, 2, 3, 4 and 5. That would be the complement, or that would be the complementary event, if you like, to rolling a 6. Okay, so let's actually have a quick look at some further examples. Okay, well, before we go on to the complements, let's actually have just a quick look at the combination of these 3 sets, A, B, and C. And you can see the first one, okay, here, this one, A union B union C. Now, that is actually all the elements in A or B or C. So let's actually just write down what they would be. Okay, they would be equal to what? Okay, they have to be in all of them. 1, 2, 3, 4. Okay, let's try and list them all out. 1, 2, 3, 4. 6. Okay, 6. 8, 9, 10, and 16. 6, 8, 9, 10, and 16. Now, you can see, after you've done this for a while, you can see why the Venn diagrams, when they were introduced by John Venn about 1880, were a very much easier way to try and picture the intersections of the sets and the unions of the sets and all these sort of problems. So basically, we're going to be moving on to what's called Venn diagrams, and we're going to try and look at these situations with the Venn diagram shortly. But let's actually quickly do A intersection B intersection C. So A intersection B intersection C, okay, which is this one here. Oops, what's happening there? I'm trying to draw on it, but okay, this one here, okay, it basically is asking us, I want A intersect B. So basically, I guess you can do it in stages. You go, okay, what could you do? Well, first of all, you just have a look at what is in the intersection of A and B. Okay, A and B, well, you can see there's the 2 and the 4. Okay, so these are the ones which are in the intersection. And then which ones intersect with C? Well, hopefully you can see that actually it's actually only the 4. Okay, which is in that. Okay, so basically the only one which is in all 3 of them, okay, you can see here, have a quick look. The 2's in A and B, but the 2's not in C. The 4's in A, B, and C. So, in fact, this one is only one element, really, okay, which is the 4. While I'm here, I may as well mention the empty set and the ideas of subsets, okay, but the empty set is actually a subset of every set, and there's an empty set symbol. Sometimes they write it like this. This is an empty set. It's sometimes written like this, okay, which means there's nothing in the intersection. But in our case, we actually have, there is an intersection element. But if there wasn't, we'd just have to say it was an empty set, the intersection. Okay, so let's have a look at the next one. Now, if we have a look, now, next one, what's this? A union B, okay, A union B, and we intersect it with C, okay. So we basically have got A union B, all those elements, and then we've got to try and intersect it with C down here. Now, okay, let's have a look. What ones would be in the intersection of A union B? Now, okay, A union B and intersecting C. Well, we can see that in C has got a 1, okay, 1 here. And in the A and the union B, there'd be a 1. Okay, so that would be a common element. What else would be, what's in 4? Well, see, you can see C has a 4, okay, and obviously there's a 4 here as well. There's also a 4 there, okay. But, yeah, but that's obviously counted for in the union of A union B. So, in fact, it looks like there's only 2 elements in this one, okay. There would be a 1 and a 4. Okay, I might try and write that in a pen that doesn't disappear. Let's actually try. Okay, so this is equal to the set of elements 1, 4. Okay. How about A intersection B union C? So A intersection B, I think we worked out A intersection B before was just the 2 and the 4, and then we have to union it with the C, so we end up getting 1, the 2, okay, now intersecting it with C, okay, because the 2 was actually in the intersection of A and B, okay, 1, 2, there's no 3, there will be a 4, obviously, okay, and we are intersecting it with C, hold on, we're unioning it with C, so we're actually adding in these elements, adding in these elements from C into the intersection of A and B. So A and B is just, A and B is 2 and 4, and we're adding in the other elements from C1, C1, 9, and 16. Okay, all right. Okay, so we have a few ideas here. Now, this is the empty set. Okay, all right. Now, so we're now going to go on to look at Venn diagrams before we actually look at complements, because it's much easier to see, the idea of a complement, something which is not in an event, with the aid of the Venn diagrams. Well, let's just have a look at this in terms of Venn diagrams, and you can see here we have the sets A, B, and C. I'm going to fix it up. As you can see, this is not the correct orientation of the sets. Each circle represents, its own set, A, B, and C. In fact, we have an intersection of A and B, and we also have an intersection with C as well. So we actually, I'm going to try and move this one across here. So there actually is elements in the intersection. So we actually have a situation where, now, do we have elements? Now, let's have a look. Let's try and orientate this. Okay, so A and C. Let's actually try and work out what's happening. Okay, so is there an intersection between A and C? Yes, 1 and 4 go in between A and C. Okay, and how about B? So actually B has that element 4 as well. So B is in the intersection of A intersection B intersection C. So they're actually, this set here will actually overlap. Now does B have elements common with C? B and C have a 4, yes. Okay. How about B and A? A and B have also a 2 and a 4. Okay, so there is an intersection in both those situations. Okay, so we're going to, you can see here, we have this is the situation. Now, just while I'm on this, if our sets don't overlap, they are said to be disjoint or mutually exclusive, but that's not the case in this situation. Okay, the situation is obviously there is actually an overlap. So an overlap, I'll just show you an overlap. Okay, you can see here what would be the intersection of A intersection B graphically. Okay, you just basically you'd have a look at, so this area here, this would be the intersection where they overlap. If I actually moved in C, where would the intersection of A and C be? Obviously you can just see there. Again, it's just here. Okay, so how about the union of A union B union C? Well, that is, I have to shade all the areas of all of them. Okay, so let's just see if I can shade all the areas. So if I wanted A union B union C in this scenario, okay, it would just be, I'd have to shade all around. Actually, you can see here, I have to shade all these bits in here. And as you can see, lovely pink. So that would be the union. But that doesn't actually represent our particular scenario. The union is just, as you can see, we just shade the whole lot of what's inside each of the sets. Okay, so let's try and fix it up now so that in fact it is a reflection of what our sets are, A, B, and C. Well, okay, we can see here I've now set up a reflection of basically what our situation is. So let's have a quick look how I've done this. Well, we know that the intersection of A, B, and C is the 4. Okay, so the 4. So the 4 is actually the only element which all of the three sets share. However, how about C and A? Have a look at C and A. They share a 4 and a 1. So the C and the A, have a look here, the overlapping part is a 4 and a 1. How about the B and the C? If you look at the B and the C, they only have one element, okay? So there's actually, if you like, only the 4, okay? And there's actually nothing over here. Okay, so they only have the element 4 there. So then all we do is we then just work out, okay, look into each circle, look at the numbers in that particular situation. Like, for instance, A has a 1 and a 4 in the intersection scenarios, and therefore, and there's also a 2 down here. So that's, as you can see here, basically an A, the only element remaining is the 3 actually over here. Okay. Okay, so that is our particular scenario at this stage. Now, let's actually have a quick look at the idea of complement now. Okay, well, let's actually just have a look at the complement. Now, the complement of an event actually is not the event occurring. So you can think of it in terms of probability, like if you roll a die, you have the faces 1, 2, 3, 4, 5, 6. The complement of the event of rolling a 6 is not rolling a 6, which is the faces 1, 2, 3, 4, and 5. But in terms of set theory, that's actually what we need to do. Is we need, first of all, the notation is a little bar straight above it. In fact, perhaps we can probably do that a little bit better with a straight line. So what we do is we actually put a little bar straight above it like this. This indicates that it's the complement of the A union B union C. And the problem here is that there's no elements which are not in the union of A union B union C. Well, there's no elements on the outside of those 3 sets. So the answer to this one is in fact the empty set. Okay, this is an empty set, or you could say it's like a symbol like this. So there's nothing if you like, on the outside of the union. Okay. Okay, so let's have a look at the next one. Okay, let's move it up a little bit. Okay, so this is not in the intersection of A, B, and C. So if it's not in the intersection, well, it's quite a lot of elements which are not in this intersection, as the only intersection is 4. So it's all the elements apart from 4. So let's actually put those in. So, okay, 1, 2, 3, not 4, right? 6, 8, 9, and 10. Okay, so these are the elements which are not in the intersection of those 3 sets. If you like, on the outside of the, you can shade it sometimes. If you want to do like a shading type diagram, you could probably think of it like it's everything around apart from that 4. So you can actually think of it, it's like, if you think of the diagram, you can shade it like this if you wanted to. And sometimes it's not a bad idea to think of it. That's a little bit inaccurate there, but you can see the idea that it's everything apart from the 4. Okay. Let's just look at these last 2 in terms of complements. Okay, so what we do, we need to put a bar above them to indicate they are complements. Okay. Now, if we look at the previous examples, A union B intersection C, there are actually 2 elements in that, 1 and 4. So basically, so this one here, okay, had elements, if you like, in the actual prior to the complement. Okay, it was actually just 1 and 4. So basically, it becomes like not 1, the elements 1 and 4. So what is not elements 1 and 4? Well, they would be elements not 1, so it's 2, 3, not 4, okay, 2, 3, 6, 8, 9, 8, 9, 10, and 16. Okay, so these are the elements, all the elements apart from 1 and 4. Okay, I think we've got them all there. Okay, if you have a look at the last one, not the A intersection B union C, there are quite a few elements in that. Well, 1, 2, 4, 9, and 16. So we basically need to look at the elements which are not 1, 2, 4, 9, or 16. Okay, you can do it in terms of shading. Okay, it's basically if you wanted to just have a quick look in terms of shading. A intersection B, okay, A intersection B is this part here. Then your union on C, hold on, oops, that's the wrong section there. It's actually over here. That's A intersection B is over here. And then your union on C, so you're adding on this part here. So you can see that's, okay, what's left is only what? You can see here 3, 6, 8, and 10. Okay. So if you actually do the shading on the diagram, you can see it a bit better. So it's only elements, what? 3, 6, 8, and 10. Okay, we're going to leave it there for today, and thank you for watching. Bye for now.